What are hydrological and meteorological data? Hydrology is a branch of water science, describing the occurrence, distribution, movement and properties of water within each phase of the water cycle. Stream flow is the amount of water flowing through a stream or river over a defined period of time. Stream flow measurements provide information on the availability of stream flow and its variability in time and space. Meteorology is the science of the atmosphere, dealing with both weather and climate. Meteorological data includes rainfall, solar radiation, wind speed, temperature, humidity, and other variables. Hydrological data, typically managed by the Water Resources Management Authority, is combined with meteorological data managed by the Meteorological Service to provide water managers with information needed for the design and operation of water infrastructure, including dams. How are hydrometeorological observations obtained? Stream flow measurements are obtained from stream gauging stations. These provide continuous records of discharge at specific points along the river or on a lake or reservoir. Stream flow can be estimated using manual methods or, increasingly, with automated gauging stations and new remote sensing applications. Stream flow measurements are combined with meteorological observations, part of a broader hydrometeorological monitoring system. Meteorological stations, more commonly known as weather stations, are often co-located with stream gauging stations. Automated stream gauging stations and weather stations can be equipped with a telemetry system that transmits data in real time to a central data logging facility. Stations without telemetry must be checked by an operator who transmits the data by other means. Types of data collected by stream gauging stations. Stream gauging stations allow technicians to check the stage, height of the water. Using manual methods, the stage can be measured visually using a staff gauge or by using a float or a pressure, optic or acoustic sensor. The flow of the stream can also be measured. This can be done by a technician using an acoustic Doppler current profiler, ADCP, which is dragged across the width of the stream. It can also be done using this simpler method of floating an object, like a plastic bottle, between two fixed points along the stream and recording the time it takes for the object to travel from the upstream point to the downstream point. The velocity of the water current can then be calculated, and computer models can be used to further calculate the discharge going down the stream in cubic meters of water per second. The discharge past a point over time is recorded on a hydrograph. This data makes it possible to establish a rating table or to plot a rating curve, which shows the relationship between stage and discharge. It's important to regularly check and recalibrate the rating curve, considering possible variations of riverbed geometry and hydraulic characteristics, especially after a severe flood. It's also important to protect the gauging station with fencing or through other means to prevent damage or vandalism.